Okay, Algebra 2 students, this is your Chapter 7, second half, 7.4 through 7.6 quiz review. Quizzes on Friday. Got a couple problems here that I would like to go over with you. Okay, so number one here, I got two problems. We're going to write each expression as a single logarithm. Okay, this is called condensing, okay? So whenever you condense, you do powers first. Powers first. So any number out in front of a log becomes a power. So this log has no number out in front of it, so that's just log 8. Minus. This log has a 2 in front of it. That becomes the exponent. Log 6 squared. Plus this log has nothing in front of it, log 3. Let's go ahead and simplify that 6 squared. So log 8 minus log 36 plus log 3. And now we have a quotient rule there. If I could spell quotient because of the subtraction. And we have a product rule there because of the multiplication or the addition. So if you're doing a quotient, you go to the bottom. If you're doing a product, you go to the top. So we have one log. So the 8 is on top because it's first. The 36 goes to the bottom. And this 3 goes on top because it has a plus sign in front of it. So this simplifies to log of 24 over 36. That's just by multiplying the 8 and the 3. And then I like to simplify this further. We can divide each of these by 12. So the final answer here would be log of 2/3. And you could put that in parentheses or not. It does not matter to me. Same thing up here. You could put this in parentheses or you don't need it. Parentheses might look neater, nicer. Okay. Okay, so that's the first one. Okay, the second one here. Again, powers first. This log, 4 log m, there's a 4. That goes with the m as its exponent. The log n has no number in front, so it's just log n. And now, this is going to be a quotient property, which means I divide them. So log, and again, parentheses or no parentheses, m to the 4th over n. Okay. Okay, next here. Now we are going to expand these logs, okay? Which means we're going to take one log and make it into many. So with this, you are going to do the powers last. Okay? So first we expand using multiplication and division. So let's see here. So we have two things up top. We have an a squared and a b cubed. That's multiplication. Then we have a c to the 4th on the bottom. That's division. So look how this works. So the a squared gets a log. So log a squared. Now the b cubed, because it's on top being multiplied, it gets a plus sign in front. And then the c to the 4th, because it's on bottom, it gets a negative sign because it's dividing. So there is your product and your quotient properties in expansion. And now all these exponents go to the front. So 2 log a plus 3 log b minus 4 log c. And that's the final answer, expanded. Okay, the second one here, so same thing. We have one thing up top, one thing on bottom. That fraction bar means division, means quotient, so we break it up using subtraction. Log base 5 of 25 minus log base 5 of x. Okay? Now, it's going to say simplify as well. This log base 5 of x cannot simplify. It's done, right? There's no powers or anything. But this right here, 5 and 25 go together. This simplifies. So remember, we're asking ourselves, what exponent do I raise 5 to get 25? Well, 5 squared is 25. So this right here is just the number 2. And the answer is 2 minus log base 5 of x. Okay. So be careful that's simplifying. It's not a huge deal. But again, if you notice the base and the other number, and they kind of go together, right? You can write them, one's the power of the other. Simplify that for us. Okay. 3 here. Solve the equation. We have one exponent. This is an exponential equation. So we're going to have to use logs to solve it. Now, the first thing I do on this left side is the base and the exponent alone. And the answer is yes. So now I use logs. So log base 2 of the third number equals the exponent. Remember, the log always equals the exponent. Okay? And now, this, I need to use the change of base formula. Log of 5 over log of 2. Remember, base on bottom. Let's get a decimal number for that. We're going to go to 3. We're going to go to 3 decimals. I don't care what the book says. So log of 5. Make sure you close that parenthesis, right? Don't forget. So log 5 divided by log 2. And I got 2.322 equals 3x minus 4. And now it's a two-step equation. Add 4. 6.322 equals 3x. I'm going to copy that up here. And then divide by 3. And I get something like 2.107. And that's your answer. In these exponential problems, you do not have to check. So this right here that says check your answer, you don't have to. Not for the exponential ones. So there you go. So there's your value of x. Okay, 4 here. Solve each equation, check your answers. Now notice these are log problems, okay? So this is going to be where we have to check our answers. Now, we are going to eventually write these logs in terms of exponents. First thing that we have to make sure the log and what's inside the log is by itself. And notice in this equation, this 2. This 2 is there, should not be there, okay? So I'm going to rewrite the problem down here. 2 log of x plus 1 equals 5. I'm going to get rid of this 2 by dividing by 2. Log of x plus 1 equals, and this is 2.5. And now I'm going to write it in exponential form. Now there is no base written, so the base of this log is 10. So 10 to the 2.5 equals x plus 1. 10 is the base. Remember, the log equals the exponent, so 2.5 is the exponent. Let's figure out what 10 to the 2.5 power is. I get 316.228. That does not equal x. That equals x plus 1, so let's subtract 1. I'm going to scroll down, actually, because of the other problem. Sorry. So I get 315.228 equals x. And before I circle that, I need to check to make sure that comes out right. So to check, just plug this answer in for x. So 2 log of 315.228 plus 1, and that should equal 5. And let's see, just plug in our calculator. 2 log 315.228 plus 1, close parenthesis. I get 5.000 equals 5, and that's good. So that is the correct answer. Okay, in the second one here, this has 2 logs. So we first need to make 2 logs become 1 log by condensing. And this minus sign means quotient. Quotient property. Log of 5 over 2x equals 1. And again, you can put that in parentheses if you want to, or not. Okay? Now, since we have 1 log, this log is by itself. Now we're going from logs to exponents. The base of this log is a 10. So we're going to go 10 to the first power equals 5 over 2x. 10 to the first power is just 10. To get this denominator gone, multiply both sides by it. 20x equals 5. And divide by 20 to get x all by itself. And 5 divided by 20 is 0.25. Now let's check this by plugging it into the original equation. Log 5 minus log of 2 times 0.25 should equal 1. So log 5. Now notice there's a parenthesis for this 5. Make sure you close it before you start doing anything else. Minus log of 2 times 0.25. And I got 1 exactly. 1 equals 1. And there we go. Okay, 3 more problems to go.
Pardon the interruption, but good morning, THS. We actually have a couple of announcements here that we...
Okay, 3 more problems to go here. Let's take a look at this log equation. Now this has an ln, which is called a natural log. So we just have to remember that the base is the number e. Okay, we handle it the same way. So is the log and what's inside the log by itself? Yes. So we're going to go from natural log to e. So that base is e. So when I rewrite it, e to the 8th equals 2m plus 3. And now I'm going to figure out what is e to the 8th. It's a big number here. So e to the 8th is 2980.958. That's the 3 decimals. And that equals 2m plus 3. And now you just solve this for m. So subtract 3 from both sides. That gives me 2977.958. That equals 2m. And I divide by 2. And that gives me 1488.979. And that is m. So again, this is a log problem, so you must check your answer. And to check this, I'm simply going to plug it back in. So the natural log of 2 times 1488.979 plus 3 should come out to be 8. The natural log of 2 times 1488.979 plus 3 equals, and I got 8.000 equals 8. That means that this is the correct solution for m. So a natural log is handled the same way, except the base is e. Okay, number 6 here. Let me scroll up a little bit. Here we go. Use natural logs to solve this. So this is just going to say solve the equation. And this is an exponential equation. It involves e, so we're going to use ln to solve. However, there is something wrong with this equation, and that is the plus 5. That is not part of the base or the exponent, so I'll rewrite e to the 3x plus 5 equals 6. I need to get rid of this 5 first by subtracting 5. E to the 3x equals 1. And now I can write this in terms of logs. Natural log, now again, this would be a base e, you don't have to write it. Natural log of 1 equals the exponent 3x. Remember, log equals exponent. And we use our calculator, the natural log button of 1. Uh-oh, that comes out to be 0. No big deal. So 0 is 3x. Just divide by 3. And the solution to this problem is 0. Okay. You do not need to check because this was an exponential equation, so that is good. So just remember, when you have e in the problem, get the e and the exponent alone and then use natural log. Okay, last problem here is a word problem. It says use this equation. I'm going to write this down. So use v equals negative 0.0098t plus c natural log of r. And what are these things? Well, v is the velocity of the rocket. T is your firing time, C is the velocity of the exhaust, and R is the ratio of the mass of the rocket filled with fuel to the mass of the rocket without fuel. Okay, whatever. Find the velocity of the spacecraft. Find V. If your booster rocket has a mass ratio of 20, so there's my R, an exhaust velocity of 2.7, so there's my C, and a firing time of 30 seconds, there's my T. So this, and we're going to ignore the last part. So this is simply just a plug-in, and can you put it in the calculator? All right. So V equals negative 0.098 times T, which is 30, plus C, which is 2.7, natural log of 20. You're just going to type that all in at once. Okay? So it's going to be negative 0.0098 times 30 plus 2.7 natural log of 20. And I get a velocity of 7.79, and I would tell you the units, they need to be in kilometers per second, just like the other exhaust. And there's your velocity. So that's a simple plug-in and just use your calculator. Okay, no solving, no log equation, now exponential, no. Just plug it in and solve. Okay. So hopefully these 7 problems help you prepare for your quiz on Friday, get another good grade like you did on your last quiz, and look forward to Chapter 8. All right, thanks for watching. We'll see you.